All right, let's look at page 25 now of 1134. And did you on page 24 figure out at the bottom, it's probably easier to do all of the radian problems at once and then switch the mode one time and then go back and do all of the degree problems. That's what I would do, just make it a little simpler. Maybe you figure that out. All right, let's look now at this next page. And they're saying that they're making the proposal that if we choose any 2 points on the same terminal side, we can get the same values for sine, cosine, tangent, secant, cosecant, and cotangent. So let's see, now they actually, if you look at the page 25, they're saying that the sine of theta is square root of 5 over 5, square root of 5 over 5, but that's not what I'm getting, or is it? Do you remember? Mathematicians made up a rule thousands of years ago saying that we're not allowed to have a radical in the denominator. So we have to rationalize the denominator, and we do that by multiplying top and bottom by the radical. So the square root of 5 pops out. I get 10 down here, and up here now I have 2 square root of 5, and then I can simplify this. I do get square root of 5 over 5, which is what they have in the PACE. The same thing happen here. I can just multiply top and bottom by square root of 5. So I get negative 4 square root of 5 over, the 5 pops out, 2 times 5 is 10, and then reduce that, and I have negative 2 square root of 5 over 5, and bingo, that's what they got, okay? Obviously, 2 divided by negative 4 is the same as negative 1/2. Now, to do and they want you to finish the problem, so do the cosecant. So you're going to reverse this and do 2 square root of 5 over 2, and then you'll see that square root of 2, the 2 cancels, and you just have square root of 5. So do that for each of these, simplify until you get out to your final answer. Now let's pop over here. What happens if we take another point on the same terminal side? In this case, negative 2, 1. So I'm going to take the y value, y over the square root of 5. How do I know it's square root of 5? Negative 2 squared is 4. 1 squared is 1. You add the 4 plus the 1, you get 5. And then we do the square root of that, okay? So square root of 5 is the r value. So I have y over r, x over r, and then this is y over x for the tangent. And then we do the same thing we did over here, just rationalize it. So we're going to end up with square root of 5 over 5, negative 2 square root of 5 over 5, and that's already reduced, negative 1/2. Look, we get the same thing, okay? And so that's one of the cool things about sine, cosine, and tangent is we can choose any point anywhere along the terminal side and still get exactly the same, because they're ratios. Ratios of sides to sides is what the sine, cosine, and tangent are. All right, I'm going to have you continue to do page 25, and we'll come back in a little bit and talk about 26 and 27.